Hello everyone, this is Mr. Zai, and in this video I'm now going to talk about the atom as well as the atomic structure. So you should have learned what the element is in the previous video. So if you can magnify a block of metal, you will find there are a pack of atoms inside the block. Also, if you can have a look on the microscopic field of a jar of gas, you can also find the molecules inside the jar, which is composed by the atoms of the element. So, if we can understand the structure of the atoms, we may also understand more about the physical and chemical properties of the substance, not even the elements. So, we may go on to talk about what the atom looks like. Since ancient Greek, the philosophers already have the concepts of atoms, and they thought the atoms as a tiny concrete balls. And this is not difficult to imagine why they have such thoughts. It is because the substance, including the solid and the liquid they have encountered and tried, are concrete, and they cannot be compressed into smaller size. Therefore, the particle, the atoms that forms the substance should also be concrete and like a ball. And in the 19th century, the scientists began to investigate more on the atomic structure, and they find that there are some positive charge and negative charge inside the atom, but they still cannot escape from the concepts of atoms as a concrete ball. So they have developed a plum pudding model that the positive and negative charge particles are packed in the atom like a plum pudding. After a more thorough investigation on the atomic structure in the 20th century, the scientists have more ideas and suggest another model of the atom, which consists of the nucleus surrounded by the electrons, and there are many spaces between the nucleus and the electron. So you can imagine that the current model of the atomic structure is like the solar system, where the sun acts as the nucleus, while the planets, including the Earth, Mars, Mercury, Venus, as the electrons surrounding the nucleus in a phase track. So let's go on to talk about the nucleus and the electrons in detail. So in this atomic model, the nucleus is at the center of the atom, and it is composed of two different types of particle. The blue balls with the positive sign are the protons, while the red ball are the neutrons. And also, the green balls with the negative sign around the nucleus are the electrons. As these three types of particles are present in the atom, so they are collectively called subatomic particles. Finally, by considering the mass and the charge of proton, neutron, and electron, we can better understand what atom actually is. First, we can consider and compare the mass of the subatomic particles. As listed in the video, you can find that the masses of all these particles are very small. However, we can still have the comparison among them. Comparing the proton and neutron, their masses are more or less the same, while the mass of electron is much lower than the former particles. So, we can use the relative mass to have a clearer comparison. As the mass of electron is 2,000 times lower than that of proton and neutron, so we can deduce that the mass of the atom is mostly concentrated at the center, that is the nucleus, instead of evenly distributed in the whole atom. Next, we can compare the charges of the subatomic particles. As you can see, each proton carries one positive charge, and each electron carried one negative charge, while the neutron does not carry any charges at all. We can explain two phenomena on the atoms. First, we can explain why electrons will move around the nucleus. It is because the negatively charged electrons are attracted to the positively charged nucleus due to the presence of protons. Therefore, the attraction will motivate the electrons to spin around the center. We can also explain the net charge of the atom based on the number of the protons and electrons. If there are more protons than the electron, that means there are more positive charges in the atom, and therefore the net charge of the atoms becomes positive. In contrast, if the number of electrons are more than that of protons, there will be more negative charges, and the net charge of the atom becomes negative. But in atom, since the number of protons are equal to the number of electrons, therefore the net charge of the atom should be zero because the positive charges are balanced by the negative charges. We can use this carbon atom to explain more on the net charge of the atom. In the atom, there are 6 protons and 6 electrons. That means the 6 positive charges are balanced by the 6 negative charges, and therefore the carbon atom does not carry any net charge at all, and this atom is known as neutral because it carried no net charge. This is the end of the video. I hope you will understand more about the atomic structure.